Hello, everyone. Welcome back. Today, we are going to go and talk about sinusoidal models. Now, this is the very last lesson in our Unit 6 and also in our course, so that's very exciting. Congrats on making it this far. Today, we are going to be talking about sinusoidal models. So, in the last video, we talked about graphing various different types of sinusoidal functions and how to do that. However, one thing we didn't really discuss is what if we want to change the period? What if the period isn't 360 degrees? What if it's something else? Well, the thing is that there's a k value to indicate that. However, k is a little bit harder because k is not the period length, right? K is equal to 360 divided by the period length. So basically, we're able to find the period length through k, or alternately, let's say we have k but we don't have the period length, we're being asked to find it. We can plug that into this equation and find the period length. So we can find the period length from knowing k, or we can find k from knowing the period length, whichever it is that we're up to that day. Whatever your teacher asks you, basically. So I'm going to give an example here. It says that the moon is almost always being illuminated by the sun. The amount of moon that is visible to us depends on where it is in its orbit around Earth. Examine the graph below and develop a sinusoidal equation that models the proportion of visible moon as a function of time. So the first thing I'm going to do is I'm going to answer all these questions. They're asking for the maximum value and the minimum value. Well, of course, the maximum is 100. The maximum is 100% of the moon that we can see, and the minimum is 0%, right? Some days we don't see the moon at all, right? And that is shown on our graph too, right? We have 0, 100, 0, 100 over and over and over again. Good. The next one says equation of the axis or the middle line. So how do we know what is the midline? Well, we can kind of just visually see that it's probably 50, but how could we find that out, for real? What we need to do is take the max plus the min and divide by 2, right? 'Cause something mentioned, I believe actually it was maybe 2 videos ago, is that the minimum plus the maximum divide by 2, or finding the something that's equidistant between minimum and maximum, is what's going to give us the midline value. So here we have 100 plus 0 divided by 2, which is 50. So therefore 50 is going to be that midline, or I should say x or sorry, y is equal to 50, right? Y is equal to 50 every part of this line. Now let's talk about the vertical shift. Well, if we're using a sine specifically and not cosine, what is the vertical shift going to look like? Well, we know that normally we start here, right? We start here and then we go up and down and then we stop here, right? That's normally how we would do it. So here it looks as though we are shifting a certain amount. Now, how much are we shifting? Well, the thing is, let's talk about how we can figure that out. Well, we know that this is an entire period. We start here, up, up, and end here, right? So we start at 120, we end at 150, right? So the entire thing, the entire period length, would be 30 days of the year, right? That's the entire thing. So if we divide that by 4, we can find out how many are in each step, right? Because we go here and then 1, 2, 3, 4 till we get back to the beginning, right? So by dividing 30 by 4, we can figure out, okay, if 4 steps is 30, then how many is one step, right? So 30 divided by 4 gives us 7.5. So that means we have a vertical shift, or sorry, that's phase shift. My apologies. We have a phase shift of 7.5. And at 7.5 to the right, this was shift, right? Because if we shifted it 7.5 back to the left, then we would have our original function. So we took our original and we shifted it 7.5 to the right. So I'll mention 7.5, and we shifted it to the right. Now, because this repeats, there's actually infinitely many correct answers for the phase shift, right? This is the most simple one, but you could argue, oh, well, what if this is the first one? And this one is right around just before 40. Looks like it's 7.5 times 5, which is 37.5. So, haha. So, 37.5 then is the phase shift. We did it 30, that's how much we shifted the original function, for example. Or there's infinitely many. We could say, oh, what about 67.5? That's another one, and so on. So there are actually infinitely many correct answers for this one that we could have taken that original equation and shifted it, is the reality here. I just chose the most simple one, and that's what I think is probably best to do. But there are a lot of, well, not just a lot of, there are actually infinitely many correct answers for that too. All right, so what about the vertical shift? So the k value, well, that is going to be the same as the midline, right? So that's going to be 50, right? 50 is our middle line, or our vertical shift. Our amplitude is also 50 because the distance between this midline to either endpoint is 50, right? If we take 50 and we add 50, we get 100. And if we take 50 and we subtract 50, we get 0. So 50 is not only halfway between 0 and 100, but it's also the distance from that middle line, which is at 50, to get to 0 or 100. So keep in mind, vertical shift and amplitude aren't usually the same thing. They just are in this scenario for that reason, but they're referring to two different things there, and that's important to note. All right, so now what I'm going to do is I'm going to make an equation using all of this information. So I'm going to say, y is equal to the amplitude, which is 50, sine times what? Well, what's our k value? Well, we know that the k value is equal to 360 over the period length. We know that the period length is 30, so that means the k value is equal to 12. 12, I believe. Yes, 12. So that means I'm going to put a 12 here. And then x minus d. Well, we know that the phase shift was 7.5, right? So I'll put x minus 7.5 there. And then we're going to go up to get to the midline. So plus 50. And there's my equation. So there we go. Basically, we had to take all this information, we had to do a lot of calculations in order to figure out what is the equation. And then by the end, we were able to just kind of plug the numbers in, as long as we know what's what, right? As long as we understand where does the phase shift go, where does the period length go, or the k value that leads us to the period length, right? Where does the midline go, all that stuff. As long as we understand that, then we're able to take this information and put it into an equation, which is fantastic. Now let's use the equation to determine the amount of visible moon after 200 days or 275 days. Now again, in this case, it does say to use the equation. However, if it didn't tell us how to find it, there is actually a second way we could find it, just by using the graph and kind of inferring that, well, this graph repeats itself over and over and over and over again. And so we could just use the graph and extrapolate on the graph to find it. Okay, but anyway, let's do it the way they said that they wanted it done. They said that they wanted to know what percent of the moon is visible. So what's the y value after 200 days? So if x is 200, so they want to know if we plug in 200 for y, what do we get? So in this case, I advise you all to grab your calculator to figure it out. So this is going to be 2310 plus 50. So what's sine of 2, 3, 10 is a half times 50 plus 50, right? And that's 75. So basically, 75% of the moon is visible after 200 days. Now, how can we check that that's right? Well, the first number one check we should do before we do anything else is we should say, well, is this in our possible range? Right? Is it reasonable to say that 75% of the moon might be visible? And yes, absolutely it is, because it's between 0 and 100. If we got something below 0 or greater than 100, that wouldn't make sense in the context of the question, nor would it make sense even just with the minimum and maximum value that we already established. However, this does make sense, so it passed check one. Let's go to check two and say, okay, well, what do we expect it to be? Right? We said the period length was 30. So if we take, 150 here and we add 30, we get 180. And then we add that again. Well, what will we get? We will get around that 70% mark if we were to extrapolate, right? Um, and so this does make good sense, right? If we think about it kind of in that way, in terms of trying to visualize, trying to extrapolate, this is okay. It makes good sense. Let's try it with 275. So this is going to be the exact same thing, except with 275. Okay, so let's give it a go. 275 minus 7.5 is 12. So here we have sine 3210 plus 50. And also don't forget we're multiplying by 50 before we add the other 50. Keep that in mind because it will change your answer if you do not do that. So make sure that you do. And here we have 25% as our answer. And again, does this make sense? Absolutely it does, right? 25 cents is reasonable. So that's our first check, is it's within our minimum and maximum range. And then let's take a look, do we think that's going to happen after 275 days? Well, let's subtract 90 from it, right? Let's subtract 30 3 times. And we get 185, so it's the equivalent of 185. Let's subtract 30 again. Get 155, let's subtract 30 again. So it's like 125, and 125 is around there. And yeah, it looks like it could be around 25%. So sounds good. The graph looks as though it is correct. Now, of course, we can't just go off the graph. The graph won't tell us the exact place. It's hard, it's not that it won't tell us, but it's hard to read the graph and be exact about a graph. So graphing as a way of solving is honestly a pretty weak strategy, but graphing is great if you already have a graph to be able to look and check and see, okay, does the graph and what the graph looks like, does it kind of match my answer, right? Or the minimum and maximum, does it kind of match the answer, right? Because just because we get something between 0 and 100 doesn't mean it's always correct. But if we don't, we know it's always incorrect. So it's good to check and make sure it does pass that check, because if it does, then it may be correct or it may not be. And if it doesn't pass, then it definitely isn't. And we definitely made some mistake. Well, very good. That's that one done. All right, well, before I let you go, I do have one more example just like this. And you know what? I encourage you to pause and give this a try yourself if you feel comfortable doing that. And then I will move on with this next example. All right, so let's do it. Let's try this next example here. It says Arya's height on a trampoline is measured and displayed in the graph below. Examine the graph below and develop a sinusoidal equation that models the height of Arya as a function of time. Okay, so first things first, what is our minimum and maximum value? Well, our minimum is 2. So seems like when, the lowest height she gets is 2. And the highest height she gets, because, right, she's jumping on the trampoline. So when she's like really high, she's, at a higher height. And then when, she's bouncing down, then she's at a lower height, right? So our maximum value, oops, I wrote 2 for maximum. I meant 2 for minimum and 14 for maximum. Then they ask the equation of the axis, the middle line, or the midline, as I like to call it, this line here. Well, we can kind of just tell that it's 8. But if we wanted to actually calculate and show how it's 8, we're going to add up and find the average of the minimum and maximum value and get that it is 8 that way. And the full equation of the line would be y equals to 8, right? It's this whole line. Y equals 8 is our middle line or our midline. Then we have our vertical shift. So how much did we go up or down? Well, we went up by 8, right? Our middle line normally would be at 0. Here it's at 8, so we went up by 8. Then we have what's our amplitude, so what's our distance from that middle line, so distance from 8 to 14, or our distance from 8 to 2. And either way, it is 6, right? It should always be the same value. If it isn't the same value, that means we didn't find the middle line correctly, right? Because the middle line is always halfway between the min and max value. And so it should always be the same distance, right? If it's equally between, truly. So that's important. Good. Then phase shift. So did we go right or left and how many? Well, again, normally we would start here, right? However, in this one, I would argue that there is no phase shift. It's just that we, and you could argue that there is one, and that would also be correct if you were consistent with the rest of the numbers. But the thing is that really we can also look at it in an easier way of just, well, we flipped the numbers, right? We had we reflected in our x-axis, so actually it does start here and then it goes down and up instead of going up then down, and that's the only difference. So I'm going to say that there is none. There is none because we really just reflected. We didn't actually do a phase shift, we reflected. Now, because this is a sinusoidal function, right? Or actually really because it's a periodic function, it repeats over and over. So one could also argue and completely be correct in saying, oh no, the phase shift was 2, right? We moved 2. Right? So that's also a correct answer. Just make sure that your equation is consistent with that if you do it that way. And that, by the way, if you did it that way, that is still a correct equation. If you went way over, that's still a correct equation, right? Maybe you did more work than you needed to in that case, in which case you could tone it down a bit, but you could still get it right, right? There's infinitely many different equations that are all correct. Now, all of them have the same vertical shift, all of them have the same amplitude and the same midline. However, in terms of the phase shift, there's lots of different phase shifts that are correct, but I'm just going to choose to not do any phase shift because that's the easiest and that is an option this time. Last time that wasn't an option, this time it is, and I'm going to take that option because it makes my life easier. Good. Then we have our period length, which is what? Well, let's take a look at it. Basically, we go up, down here, and then we do the same thing again. We repeat it again, right? Each of these is a different cycle. And so let's see. We start at 0 and we end at 4, and then 8, and then 12, and then so on, right? So every period is 4. Now, what about our k value? What does that make our k value? Well, we know that our k value is equal to 360 divided by our period length. And we already established that our period length in this situation is 4. So that means that k is 90. And now we can write our equation. We can say y is equal to the amplitude, right? In this case, the amplitude I'm going to put as 6, and I'm going to also put a negative sign to indicate that it's flipped, right? That the equation is reflected in the x-axis as compared to the original y equals sine x equation. Then we have sine times 90 as our k value, and then x, subtract our vertical shift, or sorry, not our vertical shift, our phase shift, which is just nothing. So actually we can just say 90x here because we're not doing a phase shift this time, which is excellent. We are doing, however, a vertical shift and we're going up 8. So I'm just going to add plus 8 and that's it. We're done. We're done. All right, let's try part B. It says use the equation to determine Arya's height after how many seconds? So let's see, after 44 seconds, let's plug that in. Y equals negative 6 sine 90 times 44 plus 8. That's equal to negative 6. Let's see. Sine 3960 plus 8. And that is just going to be 8 because it turns out sine of 3960 is 0. So the answer is 8. And that makes sense if we think about it, right? Because this repeats every 4 and we start at 8. And so, of course, 44 seconds, we're going to get 8. We're going to be at that very beginning of our cycle where we're getting 8. So this answer makes good sense. And also, of course, it is within the range of from 2 to 14. So that's another checkbox that we got it right. Let's do 60.5. And I have a feeling this one won't be as nice a number as the previous one because this one is a little bit more. It's 0 0.5 seconds after the start of a cycle. And how do I know that? Well, because 60 is divisible by 4, right? So 60 would be right at the beginning of a cycle. 60 would give us 8, right? 60 seconds would give us 8 as our height. So 0.5 seconds after that would be around here. So I'm expecting to get something around that range, maybe 3 or 4, or some fraction, around there, some decimal around there. Something like that is what I'm expecting. I'm certainly expecting to get below 8, but of course above 2, above our minimum point. So let's see what we do get. But that's what I'm expecting based on what the question's asking me. But let's see. Sine 90 times 60.5 plus 8. So let's see. 90 times 60.5 is 5445 times -6 plus 8. I end up with 3.757 approximately, and that is around the range that we had said. And also, of course, it's between the 2 and the 14, which is also obviously a requirement there as well. Oh, and I guess the height is in what dimensions? Was it meters? Yeah, it's in meters. So I'll put that it's meters here. And we could also write a conclusion statement, just quickly saying after 44 seconds, Arya's height is 8 meters. And then for the second one, after 60.5 seconds, Arya's height is approximately 3.757 meters. But you know what? Today is our last day. I will not keep you any longer. Congratulations on completing the course, and we hope to see you in a future course. Bye, everyone, and congratulations.